Welcome to another episode video on my ESP32 IoT device, which is currently connected to an LED. Quite simple. I2C use for this LCD, and then just ports addressing high and low for this 7-segment display. And as you can see, the G segment is off, but the reason for that is a bit, well, faulty wiring. Now it's complete, so I have to be a bit tender for that. Other change is that here was this wire, and it's a bit of overkill for a very short distance, so I replaced it, and it's still working. As you can see, the underground has changed a bit. That is because this, well, breadboard combination, which isn't ideal because the holes of this one are quite different than this one, but I'll have to deal with it. I don't have anything else at the moment, and by using this carton underground I can use it safely, because it doesn't well, it doesn't conduct any current, any voltage, and it keeps everything together, more or less. Last time also I had the problem that the LCD started doing something weird, and in order to correct it I had to reload the software. Well, so far so good. I don't know where it comes from, but it's working right now. So up to another idea. Amongst the many sensors also is an actuator, which is quite nice, a real servo motor, and this is then the micro servo 9G SG90, and it can be mounted with this one and then a screw. So that is going to be working next, and it won't use just I2C or any other high or low thing. It will use, according to my info, pulse modulation or some sign. So first thing to do is then mounting this and see how everything is working, if I get it working, because with the experiments, my experience is you never know. There may be a typo, there may be something else, and maybe going up in smoke, which of course I don't hope. So let's see how this is going to be working out. Alright, so I have taken motor mounted blade, one of 3 possible blades that are delivered with it, and then how to mount it. Well, first thing is that this wire is female, and in order to use it I can either use, once again, pins inside it, or I can use the wire that was previously on this location, which has male-male contacts. So easiest to do is use this one, and then I have stick every one in it, of course. So I can use these 3 pins to connect it. However, what I need to do is wire some pins from here. Let me use some better lighting. It needs 3.3 volts, which is this one, and for the example which I want to follow, I need 25, which is here, and I want to use the same method as I have used here. So 3.3 wire is going to be here, and 25 wire is going to be here somewhere. I already prepared 2 wires, so once again I have to be careful and lift the device out of its socket and put wires between the pins. See how that ends up. And that may be going right in the first time, maybe not, we'll see. Oh, and it needs a ground, but ground is already wired through. Ground is ground, so that will be no problem. And in the meantime I see, I was afraid that this one was doing nothing anymore. Now you can see something. Anyway, let's see how this works out. And if all examples get confusing, refer to the datasheet, which had me rewire. So orange is pulse width modulation, red is power, and ground is brown. So this is voltage, which means now I have to disregard the yellow one. So this is power. Then ground is of course quite simple. I have to stick it in here, which remains this one. Oops, and then it is nice if you see what I do. So let me remove this one. So this is power, then ground is this one, and then the orange one has to go in here, and then hopefully this one is connected correctly, because in the example it said well 25, and next thing it says, another example says D2, which is right here next to it. So which is correct, I don't know, never tried yet. And then it would be nice if this could be standing somewhere. And you can also notice by now that the display is gone, and that this LED is gone, and that this display is gone. So I have to reload anyway. Let's do that and see if things work even without the motor being controlled. So go. Well, that one works, except for the LCD that does not work. So that's no good. And the 7segment display doesn't work either. So let me once again start by removing something. Let's remove the volt here. And remove this signal. I have to support this somehow because you can't just see it, whatever happens. Alright. Reload. Now it works. Kind of. Yeah, and this is pretty hard to see, so I need to improve the contrast, but now you can see it. Alright, anyway, I have to program the motor now, and that needs a servo header file, which I have to get somewhere, and then some code. So let's see how this is going to end up, if everything is wired again. Alright, so how to actually control it. I included now the servo header file, which according to the tutorials is indeed with a capital. If I started with this, but that remained black, and this colors, so this is correct. Then what next? Well, I do have to set a pin for the pulse modulation, so I'm starting, let's say, under this, because this is LCD and this is then for servo with an S, and I make, well, it says servo pin 9, obviously for some reason, but the point is it 9? No. If I look at this, these are all the pin numbers that I've used. I have used for this one, I have used pin gpio 25, so I assume I will have to use now let's go back here, servo pin, that's or servo something is 25. Alright. Let me first compile this one, because this is now a mess, and this is a mess. Error compiling, where? Where does it go wrong? servo. Okay, I can't use the servo with this. Oh, that is not funny. Indeed. I have to look further. And that is typical because wire, which I use for I2C, belongs to the same library as, or to the same library collection as servo. So one does and one doesn't. Right. I need a new plan. Unfortunately. Alright, so now I have a bit of a problem, apart from LCD being gone nicely. This still works, this still works, but this is still a problem. The servo header file from Arduino doesn't work. That was clear. So I found this on GitHub, and this is nice. The servo library for the ESP32. So that is nice. I download it, and then I find that I had to rename things. Then, well, this you know, because this is the same as this one. Then going here, and I already had to change things because it was in here, which is in source. I don't want that, so I replaced it here. However, it still doesn't want to know it, and that is a problem. I already restarted it twice. Oh, maybe once more, because I renamed things. So once more, let's see if this works out. And that would be time number 3 that I do this. And this one, and this, execute. But unfortunately, this doesn't work. So, while this is exactly the same thing, I wonder if I should rename this one. But that shouldn't really matter, because it wasn't named like this in the first place. If I look at the download, this is how it is named, no underscore. And here is an underscore, so I put the underscore here. And this is the absolute source of it, so it has an underscore, so this should be working. Now some examples. Let's look at how. Oh, I can't open this really. Yeah, I can open this in Arduino, but this is the same thing. I might find the solution in here. Open how? Well, yeah, open in here, but it doesn't look like that. Anyway, this should be working. But because it's black, it doesn't. Okay, let me try to find out once again. Alright, and then this is interesting because in the example that I opened, which I showed you earlier, sweep, it remains black. So I'm going to compile this and then see whatever happens. This warning is okay. It works. Yeah, alright. So that means that I can just go ahead. And that is a very nice idea. Yep, and then alright, whatever, this is a wiring issue. Anyway, so this is good now. Then going back once, alright. And then this should be an example, although of course I can use the example that I found on the other one, but alright, let's see. I have to use the name of this if everything works the same, which may be a surprise. And this is unfortunately not not automatically attached, so usually you get the list, but in this case you don't, which is too bad. I can do this. So with this I can go to, this is the setup, this is the loop, and going from here see, and this is working. It would never do this if it wasn't correct. And now, how about this one? They say attach, but in this case it is a very different one because it uses servo. And this is just try out as I go. See, servo attach and servo pin. So here I have to use the previously defined pin. Going back, which, wait, okay, which did I define? Servo pulse. So here okay, that is very nice. Now let's see step by step how this is being accepted. Oh, it doesn't at all. That's not my type. Oh, that is too bad. Back to the drawing board then. Right, for time's sake, I have now written and copied some, well, not really literally copied, but some code for the servo. So this is the correct way. These are pulsed and position for servo sweep, and control of the servo motor, position 0 to 90, which is not the same as the example. Write the servo position with a delay of 30. And in here you can also see that I let the LED blink once again. Didn't test yet, so it will be a surprise to me as well, whatever will happen. Let's go. It would be 90 steps, so it should go something like these going here, I imagine. But let's wait. And now I see that it is not exactly clear on screen. Oh, there's a pulse. Oh, well, it did go, but right, step by step, indeed. Oh, that can go very slowly. And to be honest, I didn't even see it go. I have not seen it move one bit. And the signal is on the correct point, because this is pulse width. Although or is it? Yeah, it is set to pulse. And it is currently to 1 millisecond. And here you can see it is indeed pulse width modulation. This also means that it is indeed going extremely slow, because this, let me point on the camera, this means that it is going very slow. Ouch. But it's working, kind of, and I have to wrap up. Right, that is the wrap up of this episode. Just 1 second before recording this segment, I saw this move clearly. So it really does work, as you can see now also. So let's take a moment and see how it behaves. If you watch, you can see it very nicely. It moves a bit from here to here and back. And I have the impression it doesn't always move, but I clearly noticed it, so it does work. Maybe when I enlarge it to 180 or 360 it works better, but anyway. Thanks for watching. If you like this video, please subscribe to my channel. Give it a thumbs up. Leave a comment or suggestion. You can also follow me on Twitter. Please retweet, like, and leave a comment. You can also follow me on Instagram. Please like it, leave a comment. My website and my Twitter and Instagram names are under this video. And you can support my blog by making a small donation via either PayPal or Wired, and you can also choose to become a patron and have your name mentioned as a supporter on my website, but also with my videos depending on the pledge you make. Everything once again under this video and on my website. For now, thanks for watching. Bye bye.